These are the 4.1 notes for trig. We're talking today about right triangles and how to find the value of all 6 trig functions. So there are 3 sides of a right triangle. The first is called the opposite. The second is the adjacent. And the third is the hypotenuse. On your right triangle, you have your right triangle notation right there, that little square in the corner. And then this symbol right here, 0 with a line through it, that's called theta. It's a Greek letter, and that's going to represent our angle for most of the unit. So when we label our sides, the opposite side is the one opposite of the theta, so over here. And then I always do the hypotenuse next. The hypotenuse is diagonal from the right triangle, right angle, so that's the hypotenuse. And then the other side, the adjacent, is the one next to the angle. And we have 6 trig functions. You learned 3 of them in geometry. Let's talk about each one of those. First, we have sine, spelled out S-I-N-E. And sine of theta, we always use that angle symbol. So sine of theta is O over H. Cosine of theta is represented by A over H. And by A over H, I mean the adjacent over the hypotenuse. So I'm referencing the triangle again. And then tangent is O over A. And in geometry, we learn to remember that by the phrase so, ka, toa. So what this represents is the sine is O over H. That's where the SOH comes from. Same with the cosine, CAH, and the tangent, TOA. There are 3 additional ones. The next one is called cosecant. And this one always pairs up with sine because it's the reciprocal. All you have to do is change the O over H to H over O. Just flip that. The one that goes along with cosine is called secant. And that would be H over A. And then cotangent, which would be A over O. We normally shorten and abbreviate these to just the first 3 letters. So sine is abbreviated to SIN, cosine, COS, tangent, TAN. The issue with cosecant is there's already one. Cosine is already abbreviated to COS, so they're going to abbreviate this one to the letters C, S, C. Cosecant is abbreviated to CSC. Secant, again, first 3 letters, and cotangent, COT. All right, so what we're doing here is we're just setting up a bunch of fractions, proportions, on how these sides relate to each other. So the first thing we always want to do is label the triangle with O, A, and H. So your theta, your angle, is in the left corner, which means the 3 is the opposite. The 5 is diagonal from the right angle, so that's your hypotenuse, which makes the 4 the A, the one next to the angle. All right, so sine would be O over H, so we'll write that as the fraction 3 over 5. Cosine, A over H, 4 over 5. Tangent, O over A, 3 over 4. Cosecant is H over O, or you could just look at sine and flip it to 5 over 3. Secant, 5 over 4. Cotangent, 4 over 3. On to the back side, we have this next triangle where you have a missing side. So notice you have the 5 and the 12, but you don't have that long side, the hypotenuse. So what we're going to do is Find the missing side using the Pythagorean theorem. Spelling that all sorts of wrong. There we go. All right, the Pythagorean theorem, a squared plus b squared equals c squared. And the c has to be the hypotenuse. C has to be the hypotenuse. So the theta, notice, is in that top left corner this time. So the opposite side would be the 12. The hypotenuse is the missing side, and the 5 is the adjacent. So we can put the 5 and the 12 in for the A and the B in any order that you choose. And the C, the H is what I don't know. We'll solve this out. And square root that, 169. In your calculator, you can just type that in. Square root of 169. All right, so the square root of 169 is 13. That side's going to be 13. And then we'll just find our answers for sine, cosine, and tangent. So notice they're only asking for 3 answers here as opposed to all 6. I'm going to use abbreviation sine equals, cosine equals, tangent equals. All right, so sine is O over H, 12 over 13. Cosine A over H, 5 over 13. And tangent O over A, 12 over 5. For example number 3, we have a square root as one of our sides. We want to make sure that we leave it as a square root. We don't want to use decimals in this unit. No decimals. So we'll label our sides. Theta is in the bottom right corner, so this is opposite, adjacent, and hypotenuse. We'll need to find that missing side. Again, make sure the hypotenuse is the C value. And when you square root and a square, you have both in the same time. Those actually cancel each other out. Those are opposite operations of each other. So we just end up with the number 3. Subtract 1 from both sides to get 2. When you square root 2, you get a decimal. We don't want to leave it as a decimal, so we will leave it as the square root of 2. Put it on that side right there. All right, now we're going to ask to find all 6 trig functions. So sine of theta equals O over H, radical 2 over radical 3. Now the thing about this is we are not allowed to leave a square root in the denominator. It's one of those rules that mathematicians have come up with, similar to reducing fractions. So what we're going to do is we're going to get rid of the square root in the denominator by multiplying by the square root of 3. And whatever you do to the bottom, you have to do the same to the top. In the numerator, the square root of 2 times the square root of 3 gets you the square root of 6. Just multiply the numbers. At the bottom, here's what happens. You have the square root of 3 times the square root of 3, which gets you the square root of 9. And the square root of 9 is 3. And that's how you get rid of the square root in the denominator. So final answer for sine, radical 6 over 3. Let's do the same thing for cosine. Cosine A over H, 1 over radical 3. Similar situation here. We're going to multiply by radical 3. In the numerator, 1 radical 3 just becomes radical 3. And the denominator I have that same exact problem, so I just end up with a 3. For tangent, I have O Radical 2 over A, 1. I like that because the 1 doesn't need to stay there, and I'll just shortcut it to radical 2. Okay, for the next 3, I have cosecant, which is h over O, radical 3 over radical 2. Or remember, you could flip the sign. When you flip sign, you're going to want to make sure that you flip this one, not the final answer. Always flip the original. All right, we'll multiply this one by radical 2 over radical 2, which gets us radical 6. And then notice radical 2 times radical 2 is radical 4, square root 4. And that gives us a regular 2. All right, secant, h over a. That one's pretty easy. I don't need that 1 there, so I'll simplify it to radical 3. Cotangent, 1 over radical 2. I'll have to simplify that one. Get rid of the denominator. Radical 2 over, and we've already done that, so that would be 2. Again, that's called rationalizing the denominator. All right, this last problem is one I pulled from Delta Math, so it's pretty much asking the same thing, but in a slightly different way. So what if there is no theta? Notice on this triangle, there is no theta. What's happening is they are using the letters A, B, and C for their triangle, which I don't love because we're already working with A as adjacent. So that's why we always use theta. But for this problem in Delta, they did not choose to use theta. So what we'll do is wherever they give you the A value, that's where you're going to put the theta. So notice the A in the corner here. We'll put our theta right there. From there, then you can do the opposite, the adjacent, and the hypotenuse. And you can pretty much ignore the letters A, B, C. All right, tangent of A, which you would normally write tangent of theta, both would be correct, is going to be equal to O over A, 7 over 5.